Hello and welcome to another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 8, Mixed Up Decimal Practice. This is the last lesson in our Unit 3 on decimals in NGen Math 6. Alright, and what I want to do today is I want to throw a bunch of different problems at you that involve decimals. Some of them are going to involve adding or subtracting decimals, some multiplying or dividing, and some of them are going to have some of each in them. Right? And what we need to do is not only understand all the algorithms in order to actually do the multiplication, but we also need to be able to distinguish which of the operations we need to use. All right, so we're going to be talking about all of that as we go through our mixed up decimal practice. Let's get right into it with exercise number 1. All right, here we go, exercise number 1. Michael currently has $12.50 saved up. He's going to save $2.75 per week for the next 5 weeks. After 5 weeks, how much has Michael saved, including the initial $12.50? Show the work that you use to find your answer. All right. Well, again, all of these problems, every single one of them, is a review problem. So what I'd like you to do is pause the video now, try this problem, see how far you can get in it, and then we'll go through it. All right, so let's think about it just a little bit. So Michael currently has $12.50 saved up. That just kind of is what it is, right? The real key is that he's going to be saving up $2.75 per week for the next 5 weeks, and we want to figure out how much total he has saved. Now, of course, if we had said something like Michael has $10 saved up initially, and then he's saving $3 per week for 5 weeks, you might be able to even do the calculation in your head. Right? We would be taking that, $3 per week for 5 weeks. We'd do 3 times 5, we'd get 15, we'd add it to the original 10, and we'd get 25 total dollars. All right? What makes this problem a little bit more complicated, of course, is those decimals. And what we should probably begin with is simply taking that $2.75 per week and multiplying it by the 5 weeks that he's going to save. All right? So let's do that first, right? We've got our $2.75 and we're multiplying by 5, right? Because he's saving that per week for 5 weeks. Here we go, let's do a little multiplication. 5 times 5 is 25, carry the 2. 5 times 7, 35, plus another 2, 37. 5 times 2 is 10, plus another 3 is 13. We note that we have only 2 decimal places, so our answer has to have 2 decimal places. Now, of course, that $13.75 is not the final answer, right? That's the total amount that he's kind of saved over those 5 weeks. What we now want to do is take our $13.75, add it to our $12.50 to figure out the total amount that Michael has saved. That's just simply adding decimals. Why don't we do that over here? So we've got $13.75, make that decimal point a little bit bigger, plus $12.50. Add those. This is just like adding normal numbers without decimals, right? And what we find is that in total, Michael has saved $26.25, or of course, $26.25. All right, that's it. Pretty easy, right? This simply was all about taking a decimal quantity and multiplying it by a whole number, and then adding decimal quantities. Let's keep moving on and see what other operations we might end up having to do with decimals. Let's see about exercise number 2. Janelle has 8 meters of ribbon that she cuts into pieces that are 0.65 meters long. Letter A asks us, what is the greatest whole number of pieces that Janelle can cut from this ribbon? Show how you arrived at your answer. All right, so literally, let's kind of picture this for a moment before we actually kind of get into it. We've got this piece of ribbon, whatever, and it is 8 meters long. All right, and we're going to be cutting it into very tiny pieces, right? Each one of which is 0.65 meters long. Right? We want to know how many whole numbers of these pieces we can create. So what I'd like you to do again is pause the video now, think about just problem A, not problem B yet, all right? And think about what operation you're going to need to use to figure this out, and then try to actually do that operation. And then we'll go through the problem. Well, this is literally almost the definition of division, right? This is that kind of like part of division where you're thinking to yourself, how many 0.65s go into 8, right? And that's a little tricky to think about, but I literally want to divide 8 by 0.65. Now remember, with division of decimals, which might be one of the harder things to do, we're going to take that decimal point and we're going to move it 2 units to the right to make that 0.65. Let me make the decimal point a little bit bigger. That 0.65 into a 65. We're then going to also move the decimal place 2 units to the right on the 8, making it into an 800. All right? So all of this, after I move the decimal points, simply becomes 800 divided by 65. So let's go through this division, right? 65 goes into 80 one time, right? And when I do the subtraction, I'm going to end up with a 15. All right, I'm going to then drop my 0 down. Let me think. 65 into 150, let's try 2 times. What do we get? We get 130. When I subtract this, I'm going to get 20. All right, put a little point there and a little decimal point there. All right, drop that 0 down. All right, maybe I'll have 3 here, and that will give me 195, I think. Yep, subtract and I'll get 5. I could drop another 0 down. All right, but I don't need to take this any further. All right, this thing could keep going on for a while. It could end up terminating. It could end up having like a repeated decimal. It really doesn't matter. Because ultimately speaking, we want to know how many whole number of pieces. What is the greatest number of whole pieces that we could get out of this? Well, we're going to get 12.3 ... pieces. So that means the greatest number of whole pieces that we can possibly get is 12. Now, this isn't about rounding down or rounding up or anything like that. Quite frankly, if we had 12.7 here, the answer would still be 12 because we can't get 13 pieces out, right? We can only get 12. Now, given that that's our answer to part A, let's look at part B. If Janelle cuts this many pieces of ribbon, how much ribbon will be left over? Apparently, I really want to talk about rhythm and not ribbons, but we're talking about ribbons here. So what I'd like you to do is pause the video now and think about how you can figure out that if Janelle cuts 12 pieces of ribbon that are 0.65 meters each, how much ribbon does she have left over? Pause the video now and see if you can figure this out. Well, there's a few different ways to do this problem, but ultimately speaking, what we want to do is we want to figure out how much ribbon she used up, and we can do that by taking that 0.65 meters and multiplying it by 12. That's going to tell us just simply how much ribbon that Janelle actually used. So let's go ahead and do that. Let's do 0.65 times 12. All right. Go ahead and do this. Well, 2 times 5 is 10, 2 times 6 is 12, plus another 1 is 13. Put a 0 down, multiply 65 by 1, that's pretty easy, we get 65. When we add these together, we get 0.87. We look at the number of decimal places we have, just 2. So Janelle uses, she uses 7.8 meters of the ribbon. So those 12 pieces that she used at 0.65 meters per piece used up 7.8 meters of the ribbon that Janelle had. Now the issue becomes how much was left over. Well, that's all about subtraction, right? Because now what we can do is we can take the 8 meters that she started with, subtract off the 7.8 meters that she used. This is a pretty easy problem. You can probably do it in your head, but if not, it's pretty easy to just do 8.0 minus 7.8, and we get 0.2 meters of ribbon left over. All right? So it's a great example of both where we use division to figure out how many things that we have, how many of these things fit into that thing, and then also both multiplication and subtraction of decimals. All right, let's do a little bit more mixed up decimal practice. Here we go. Exercise number 3. Vinny buys 3.8 pounds of onion that cost $2.75 per pound and 9.4 pounds of potatoes that cost $1.35 per pound. How much did Vinny spend in total? All right, awesome. So again, pause the video now. This is going to take you a little bit of time, but see to work through the problem and see if you can figure out how much Vinny spent in total. All right, let's go through it. Now again, I always want to encourage you that if the numbers weren't decimals, if Vinny bought, let's say, 4 pounds of onions that cost $3 per pound, maybe I just round both of those up. That's 4, let's say that's 3. Then how would I figure out how much he spent in onions? Well, I'd take my 4 pounds of onions, multiply it by $3 per pound, and I'd get $12. Likewise, right, if I had 9 pounds of potatoes at, let's say it was $1 per pound, what would I do? I'd do 9 times 1, I'd get $9. We want to do exactly the same thing here. The plain fact is the math's going to get a little bit messier. So to figure out first how much Vinny spent on onions, we're going to take our 3.8 pounds of onions, multiply it by the onion per pound cost of onions, which is $2.75, to figure out how much we spent there. All right, so let's do it. I'm going to do $2.75 per pound times 3.8 pounds. 8 times 5 is 40, carry the 4. 8 times 7 is 56, another 4 gives me 60, carry the 6. 8 times 2 is 16, plus another 6 gives me 22. Put a 0 down, 3 times 5 is 15. I'm going to erase these guys so it makes it a little bit easier. 3 times 7 is 21, plus another one is 22. And 3 times 2 is 6, plus another 2 is 8. Add all of these things up. Note that we have 3 decimal places, 1, 2, 3, and it looks like, at least on onions, that's a lot of onions, Vinny is going to buy $10.45 in onions. Now what we want to figure out is how much Vinny is going to spend on potatoes. And it's going to be the same idea. We're going to take $1.35 per pound on the potatoes. The 9.4 pounds of potatoes, we're going to multiply them together to figure out how much he spent on potatoes. Here we go. So I'm going to have my 135 times 9.4. You just got to be careful here. 4 times 5 is 20, carry the 2. 4 times 3 is 12, and another 2 is 14. And 4 times 1 is 4, plus 1 is 5. Put my 0 down in my standard multiplication algorithm. 9 times 5 is 45, carry the 4. 9 times 3 is 27, plus that weird looking 4 is 31. And 9 times 1 is 9, plus another 3 is 12. Add them all together and maybe put a little dividing line so we're not overly confused. 0, 9, 6, and 12. Again, we have 3 decimal places here, 1, 2, 3. So it looks like Vinny spent $12.69 on potatoes. All right, so $10.45 on the onions, $12.69 on the potatoes. We want to know the total cost, so we're going to add these two together. All right, let's do that final little piece. So we've got our 10.45, 10.45, 12.69, easy enough. And it looks like for $23.14, let me just make sure, looks good, Vinny is going to have a lot of potatoes and onions. I don't know what Vinny's going to do with them, but he's got a lot, because for $23.14, you can buy a lot of potatoes and onions. All right, and again here, what we primarily did, we had no division, we had no subtraction, but we definitely had to multiply some decimals, big time. And then of course, the sort of the easiest thing that we do with decimals is add them. All right, let's keep going, right? We're just getting more practice on things that we should already feel fairly comfortable with in terms of decimal manipulation. Exercise number 4. A local frozen yogurt shop sells its yogurt and toppings for $0.45 per ounce. Letter A says, if Felix bought 8.4 ounces of yogurt How much did it cost? Show the work that leads to your answer. All right, yet again, this isn't so different from the last problem that we did. I'd like you to pause the video and see if you can figure out the answer to letter A. All right, well again, if for some reason, Felix was spending $2 per ounce, that would be very expensive yogurt, but if Felix was, paying $2 per ounce and bought like 8 ounces of yogurt, we'd do 8 times 2, we'd get $16, and we would kind of move along on our day. The only difference here is that we've got to take that per unit price of 0.45, right, and we have to multiply it by that kind of obnoxious 8.4 ounces. But that should give us the total amount that we spend on yogurt. So let's do that right away. Here we go. 0.45 times 8.4, right? So 4 times 5 is 20, carry the 2. 4 times 4 is 16, plus another 2, 18. 0, 8 times 5 is 40, carry the 4. 8 times 4 is 32, plus another 4 is 36. 0, 8, 7, 3, 7. I've got 3 decimal places, 1, 2, 3, and whoops. And I can't make the dollar sign, but that's okay. Who needs to be able to make the dollar sign? So Felix spends $3.78. Simple enough. Now for the slightly harder one, letter B. Felix's friend Lucas spent $4.86 on yogurt. How many ounces did he buy? Justify your answer. Now, a little bit of reasonableness before you do this problem, and then we go over it. Felix spent $3.78 on 8.4 ounces of yogurt. Lucas spent more. So, we should, at the end of the day, find out that Lucas bought more than 8.4 ounces of yogurt. And in fact, if we don't, then something went wrong in the way that we did the problem. All right, pause the video now and see if you can figure out how many ounces of yogurt Lucas bought. All right, well in this case we have to kind of go in the reverse direction that we did in A, and instead of multiplying, we need to divide. So we're going to take our 486 and we're going to divide it by 0.45 to figure out how many ounces he bought. Here we go. So the problem itself is this. 0.45 divided into 4.86. Now, since dividing decimals is sort of the newest thing that we've been doing, right? A little review again. In order to really do this division, what I'm going to want to do is move that decimal place 2 units to the right, and likewise 2 units to the right. So whereas it used to be 4.86 divided by 0.45, it will now become, after we move these, right, it will become 45 divided into 486. Right? I'm going to leave that original problem over there, give myself a little bit more space, and let's do it. 45 goes into 48 one time, right? So we get 45, subtract, we get a remainder of 3, which is awesome. Then we're going to drop the 6 down. Now, just for a second, let's talk about this for a moment. This can be very, very confusing for kids, right? Because they'll say something like, well, 45 doesn't go into 36, so I'm going to put a 0.0 there and I'm going to drop that down. Look, if we've already done the drop down once, right, we've already brought that 6 down, and then what we've got here doesn't go into that because it's too small, then we got to put a 0 up here. All right, literally. We need to say, well, that's 0 times, right? So we put 0, we subtract, and we get 36. Now is where we put that decimal place, and we bring that 0 down. Now we figure out how many times 45 goes into 360. I believe that's 8 times. Let me just check though. If I put an 8 here, 8 times 5 is 40. And 8 times 4 is 32, plus another 4 is 36. Fantastic. Subtract. And it looks like our friend Lucas bought 10.8 ounces, which has the greatest abbreviation ever, Oz. Where the Z comes from, I have no idea. But he bought 10.8 ounces. A good example right, of where we might have to use division of decimals. All right, let's keep going. Let's see what exercise number 5 has for us. While at the movie theater, Sophia buys 3 drinks, each of which cost $5.75, 1 box of popcorn, which costs $7.35, and 2 boxes of candy, each of which cost $4.28. Letter A asks us, very understandably, how much did Sophia spend in total? Justify your answer. All right, awesome. We've all been there, right? We've all probably been at the movie theater and, spent a lot of money on food. So what I'd like you to do now is pause the video and figure out how much Sophia spent. All right, well, this isn't too bad, right? Because it's all about taking decimal quantities and multiplying them by whole numbers, right? So first things first, let's figure out how much Sophia bought in drinks, right? She bought 3 drinks, but each one of them cost $5.75. So let's figure that one out, right? We've got the drinks, maybe I'll label it like this. The drinks at $5.75, those sodas are always so expensive, times 3. Right? We've got 15, carry the 1, 21, 22, carry the 2, 15, 17, 2 decimal places. So there we go. Sophia spends $17.25 on drinks. Now, the popcorn, right, there's really nothing we need to do there. 1 box of popcorn at $7.35. So I'm going to write down the popcorn just so that we don't forget about it, but there really is nothing that we particularly need to do with that. We just know that we spend $7.35. But finally, we also have the candy. And the candy, right, 2 boxes, each at $4.28. So very similar to what we did at the beginning. We're going to have $4.28 times 2. Right, that's going to give us 16. Carry the 1, 5, 8, 2 decimal places. And there we have it. That's how much we spend on candy. Now, obviously, to figure out how much we spend in total, what we're going to want to do is we're going to want to add up these 3 decimal quantities, and that's how much we're going to spend in total. So let's do that. Maybe I'll give myself a little column here. We have 17.25. Maybe, there's my 2, sort of, plus 7.35 plus 8.56. All right, here we go. Adding 3 numbers. We have 5 and 5, which is 10, plus another 6, which is 16. Carry the 1. I have 2 plus 1 is 3, plus another 3 is 6, plus 5 is 11. Carry the 1. 1 plus 7 is 8, I think. 8 plus 7 is 15, and another 8 is 23. And 2 plus 1 is 3. So, a grand total, most of which was spent on drinks, $33.16. All right? Again, not too bad, right? It's mostly about the multiplication of whole numbers, of decimal quantities by whole numbers in this problem, and then of course just adding some whole numbers at the end. Now, there's a second part of this problem, right? Letter B. If Sophia pays for the food with 2 $20 bills, how much does she receive in change? All right, pause the video now and see how much Sophia gets back in change. Well, we want to watch out because what we certainly wouldn't want to do is take our 33.16 and subtract off 20, right? Number one, I don't think that the movie theater would be very happy if she tries to pay for a $33.16 bill with only $20. But she's got 2 $20 bills, right? So in total, she's got $40. We want to subtract off the 33.16 to figure out how much she's got. All right, here we go. So simple enough, 40, and maybe I'll put a 0.00 there, minus 33.16, just a lot of borrowing here, right? We'll take that down to 13. That's a 10, but it'll become a 9. That becomes a 10, but it'll become a 9. And then finally, that's going to become a 10. 10 minus 6 is 4. 9 minus 1 is 8. 9 minus 3 is 6. And so she gets $6.84 back. All right, making some change, that's all this is. Okay, let's keep moving on. Let's see what else we have in store for us in our last problem. Exercise number 6. Akeem is carrying water in a bucket, but is unsure how many gallons it holds. He knows that the bucket and water weigh 32.49 pounds together. The bucket alone weighs 2.61 pounds, and water weighs 8.3 pounds per gallon. How many gallons of water is Akeem carrying? All right, this might be the most challenging of the problems that we do today. Thankfully, it's the last one. So pause the video now and see if you can figure out how many gallons of water Akeem is carrying. All right, well, the first thing that we really want to do here is we want to figure out the weight of the water that Akeem is carrying. Right now, Akeem knows that he's carrying 32.49 total pounds, but of that 32.49, the bucket weighs 2.61 pounds. So what we're going to do is we're going to subtract that 2.61 from the 32.49 to figure out simply the weight of the water that Akeem is carrying. So let's just start with that step, right? We've got our 32.49. We're going to subtract off 2.61. So let's see, 9 minus 1 is 8. Here we're going to have to do a little bit of borrowing. 14 minus 6 is also 8. And then 31 minus 2 is 29. So just to be clear, those are the pounds of water that Akeem is carrying. Now, what do we do with that? Well, we divide the number of pounds of water that Akeem is carrying by how much water, or sorry, how many pounds of water there are per gallon, right? You see that rate? 8.3 pounds per gallon. So now we got a little division here, right? We need 8.3 divided into 29.88. And just like all decimal division problems, what I want to do is I want to change this thing by moving it 1 decimal place to the right into an 83. And then I'll take this decimal place, move it 1 decimal to a place to the right, which will make this 298.8. So I'm going to rewrite that problem just down here. 83 divided into 298.8. And let's do that division. Well, we can think about it this way. We can kind of think about 8 going into 29, and that's going to be maybe 3 times. Definitely maybe not 4 times. 3 times 3 is 9. 3 times 8 is 24. All right, we're going to do a little bit of subtraction here. Got to do some borrowing. 8 here, 18 here. It's going to give me a 9 and a 49. 49 is good because it is less than 83, right? So now I'm going to drop my 8 down. Now I have to wonder how many times 83 goes into 498. Let's try 6 times. 6 times 3 is 18, carry the 1. 6 times 8 is 48, plus 1 is 49. Ah, fantastic, a remainder of 0. So it looks like Akeem is carrying 3.6 gallons of water. Awesome, right? A little bit tricky, of course, because of just having to first do that subtraction. Oftentimes we have to do the division or multiplication first before we do the subtraction or addition. But here we've got to subtract off the weight of the bucket to figure out the weight of water. Then we divide the weight of the water, I guess, which is up here, 29.88, by how many pounds of water there are in every gallon. That then gives us the number of gallons. All right, let's wrap this up. Now, we didn't do anything new in the lesson today, right? In the lesson today, we simply looked at a lot of different problems, many of which involved money, right? But a lot of different problems that had decimals in it. Sometimes we had to multiply, sometimes we had to divide, sometimes we had to add or subtract, and many, many times we had to do multiple operations to solve a single problem. All right. It's important to really think about what you're doing when you deal with decimals or fractions or other types of numbers. And if you ever struggle with the particular type of number that they give you, think about like replacing those numbers with whole numbers and seeing if it makes more sense to you. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.